Okay, we're going to do question 5 of the June 2011 M1 paper. This one is on moments and equating forces around different points of support, etc. And I've done the drawing for you so that we don't take a lot of time in making it, but hopefully you're okay with drawing these things by now. You have a plank that goes from P to R, and somewhere in the middle there's Q. They tell you exactly the lengths. P2, the whole plank is 8 meters long, and P2Q is 6 meters, so the Q is closer to R than it is to P. So it looks like this. There's P to R is 8 meters, P2Q is 6 meters, so Q to R will be 2 meters. Then there are two supports, one support at P and one at Q. And they tell us here that the support, the force on the support P is equal to the force on the support Q. So I've labeled them both with equal arrows. The letters I'm going to give to each one are just R and R, because they tell us that the support on both those two are the same value or magnitude, which makes the algebra a little bit easier. And then they say there's a child of 40 kilos standing at a distance of 2 meters from P. So that's 40 kilos standing at 2 meters from P, and at the center it's a uniform plank and it's got a mass of 20 kilos. So here in the middle at 4 meters I've put 20 G for the weight going down. And then they say that there is a block with mass M kilos placed at the plank at the edge of R, and so we don't know the mass of it, big M and small g at placed at R. So this is the system we have after the diagram. That takes about I don't know, 3 minutes to draw or something like that if you do it carefully. And so this question is for a lot of marks, and you'll see that if we choose our moments carefully, we're gonna get a very large number of marks very quickly. It's not a time-consuming question if you do it properly. So the first task they give us is to find what the value of R is. Okay, and what I want you to pay attention to here is we're going to take moments from one of the points of the plank, and choosing where you take those moments from is important. Sometimes it's more arbitrary than in other cases, and you can just take it at different points. It doesn't make too much of a difference. But here it does make a difference, because we have two unknowns only. We have R, we don't know, and we have M. We don't know those two, right? But depending on where we choose our moments, our equation is going to have a larger or a smaller number of unknowns. For example, if I choose moments about Q, my equation is going to have, it's not going to have this R, because this force won't play a part in the moments, right? But it is going to have this R in the equation, and it's going to have this M. So now I'm in a place where I have two unknowns, and I'm going to have to get involved with another equation and do some algebra, and that could get really messy. So let's see if we can find another way of doing it so that we only get one unknown. And there is one. It won't work either if we choose this guy as a place for moments, because then we're going to have this R participating and that M participating. Similarly, if we take them in the middle, we're going to have both R's and M and so forth. So what happens if we choose this point here, R? Well, we've now eliminated M from the system, so as long as we do that, M won't appear in our equations. So always it's good to choose a moment from a place where there is one of the unknowns, and then the whole equation is going to be in terms of only R, and therefore there's only one unknown in the equation. We're going to be able to solve it. So let's do that. Let's take moments about R and see what happens. Forces going clockwise are these two, R and R. One of them acts at 2 meters, so that's 2R. The other one acts at 8 meters, so that's 8R. And that has to be equal to forces going in the other direction, so the anti-clockwise forces, which are these two here. 20G acts at 4 meters, because that's the center of mass, so that's 80G. And added to that, because it's in the same direction, we have 40G at 6 meters, because that's 2 meters, the whole thing is 8, so that's going to be 6 from R to there. 6 times 4 is 24, so that's going to be 240G. So nice and easily now we have an equation to solve for r. We have that 10r is equal to 240 plus 80 would be 320 g. If we divide by 10 we have that this is going to be 32 g for r in newtons. Okay, we can work that out or we can leave it like that for now. And look how quick that was. And now if we want to solve the next part of the question, which says find the value of m, we just need to resolve vertically or choose different moments, but I tend to want to resolve vertically, it tends to be quicker, about resolving vertically. So what does that mean? Well, all the forces down equal all the forces up. Up we only have 2 times r, right? This r and that r. And that has got to equal all of the forces going down, which is 40g plus 20g, which is 60g plus mg. Now we know that r is 32g, so 2 times that's going to be 64g equals 60g plus mg. Therefore I take the 60g to the other side, I end up with 4g equals to mg. We cancel the g's on both sides. That's not a very good cancelling. Cancel the g on both sides and we end up with big M is equal to 4. In other words, why don't I write 4 kilograms? Because they tell me here that it's m kilograms, so m is just a number, so the value of m is just 4. I don't need to add the kilograms. The value of m is 4 because the expression was m kilograms, right? So m is just the value and the kilograms was already there, so we're being asked for the value, that is just the 4. Okay, and r is 32g newtons. We can calculate that in newtons also by just multiplying it by 9.81. That's no problem. So look what we just did. That's how easy it was to get the 10 marks, and the 11th mark just says to state how we have used the fact that the child and the block can be modeled as particles. And for that it's important to look at the wording. If you look here in the mark scheme, we can check that we got the right value for m, which is 4, and 32g for they call it x, I called it r, 32g, which is 310 newtons, 314 newtons. If you do it right now with a calculator, you should get 32 times 9.81. 32 times 9.81 is 313.92, right? But that is just 314 newtons for r. Or you can call it 310 newtons to do significant figures. Okay, the examiner accepts both of them, so you can have both of them, that's fine. Pay attention to how many marks you get for just methods. Look, just for writing down the equations you get marks. Okay, another one, you get marks for all the stuff that you write down if it's correct. So make sure your working is clear. Not only you get marks for the answers, they get only 1 mark. So you get marks for all the working, so make sure that is clear what you're doing. Okay, and here is the statement for the next part. The masses are concentrated at a point. The weights act at the point. So even though the child has some volume and he wouldn't be a point like this, the child would be like some shape with a particular volume and everything. We assume that we model them as particles, but because we've taken all the weight to act at one point. So no length, there's no distribution in this sense for the weight. Is just acting at one point, so we'd be modeling them as particles in that sense. Okay, that was 11 marks and that took a very short amount of time, so hopefully that gave you a little bit of a positive outlook on these types of questions. The key again was to choose the moment on the place where there was one of the unknowns. Okay, that can be very handy. Alright, I'll see you in the next video. Take care.